All right, folks, let's start talking about functions. We begin this section. We're going to do for 2.1 through 2.5, we're going to skip 2.3 and 2.4, no big deal. But we start to investigate functions. What is a function? Characteristic of a function. Some people think like X and Y, input and output. Some people think like domain and range. These are all good things. Some people think of a function as passing the vertical line test. And that's a good idea as well. But the absolute definition for a function, you need to have this memorized perfectly. And what it is it's a relation. And it's a special kind of relation. And a relation is simply something that expresses a relationship. So for example, just the coordinate 1, 3 is a relation. It has a domain of 1 and a range of 3. And so the input 1 gives you an output of 3. You could also have, say, y equals 2x plus 1. That's also a relation as it maps a bunch of different points. For example, say 4 and 9. Now, here's what's special about the relation. A relation in which every element of the domain corresponds to exactly one element in the range. Relation in which every element of the domain corresponds to exactly one element in the range. So with functions, you can trust that given one input, you get one output. The function is named f. It says define f of -3. That simply means that wherever there was an x, I put a -3. So 3 times -3, you can see how the x goes in, or the x value goes right there, minus 5. And so we get -9 minus 5, or -14. F of 0 is going to be 3 times 0 minus 5, or -5. F of 2 is going to be 3 times 2 minus 5. So that would be 6 minus 5 is 1. F of A, I'm simply going to put an A value. And I get 3A minus 5. F of A minus B, 3 times A minus B minus 5, or 3A minus 3B minus 5. F of x is x squared minus 2x. We'll evaluate those same things. F of -3, -3, we square it, and then we subtract 2 times -3. So I get 9 plus 6 is 15. Then I have f of 0. 0 squared minus 2 times 0 is 0. F of 2. I get 2 squared minus 2 times 2, or 0. Now some people say, well, then it's not a function, because look, you got the same thing twice. No, that means that if you plug in 0, you get 0, and if you plug in 2, you get 0. You see, the definition is a relation in which every element in the domain corresponds to exactly one element in the range. They can correspond to the same range element. 0 goes to 0, and 2 goes to 0. I like to think of it like this. Suppose you're playing soccer, and you have player number 0 and player number 2. Can they both score 0 goals in a game? Yes, they can. Could they both score 3 goals in a game? Yeah, that's possible. Could player 0 score 1 goal, and player 2 score 4 goals? Yeah, that can definitely happen. What can't happen is this, is you can't have player 0 score 4 goals and player 2 score 1 goal and 5 goals. That's not possible. So when the input gives you more than one output, that's where it ceases to be a function. But you can come up with the same output. F of a, that's going to be a squared minus 2a. And then f of a minus b. We have a minus b, quantity squared, minus 2 times a minus b. And if we FOIL that out, we get a squared minus 2ab plus b squared minus 2a plus 2b. And there are no terms that combine there. Okay, so function values. I think you know how to do that. But what is this stuff here? This is called a piecewise function. And piecewise functions are multiple functions for different domains. So for example, this function is 2x minus 1, and it's negative 1/2 x squared minus 3/2 x. But it's only one of those depending on which x value you choose. So if the domain value, the x value, is less than 0, you use the top one. If the x value is greater than or equal to 0, you use the bottom one. So that's your domain value off to the side there after the semicolon. So we can't evaluate f of a and f of a minus b, but we can do f of negative 3. And f of negative 3, I'm going to plug negative 3 into the top one because negative 3 is less than 0. And I get negative 6 minus 1 is negative 7. Now I plug in 0. And 0 is going to go into the bottom one because it's for x less than or equal to 0. And you can see I will get 0 in that situation. And then f of 2. Plug it into the bottom because 2 is greater than or equal to 0. Negative 1/2 times 2 squared minus 3/2 times 2. 2 squared is 4. 4 times 1/2 is 2, so negative 2. Minus, let's see, the 2's will cancel here, so it's minus 3, so I get negative 5. So that's that result, and that's that result. F of negative 3, f of 0, and f of 2. Negative 3 is less than negative 1, so I'll plug it in the top one. 5 minus negative 3 is 8. The cubed root of 8 is 2, times 2 is 4. 0 is between negative 1 and 2. There's no x value here, it just says that the value is always 18. And then 2 is greater than or equal to 2. So I plug it in the bottom. 9 times 2 is 18, minus 2 is 16. And there you have it. So be able to evaluate functions in both those situations. Now I come across something very interesting, and that's called the average value or average rate of change of a function. And I want to kind of give you this idea. It's an idea that we're going to get in calculus. But we like to talk about average rate of change of functions. And so suppose you have a function that looks like that. And suppose that you have this a value right there. Then that means that the y value is f of a. So you would plug a into the function and you would get f of a. Now I'm going to move over h units to a spot called a plus h. You can see that a plus h is h units away from a. And so this value is f of a plus h. Well, average rate of change of a function is defined by the slope. And so if I connect these 2 points, you can see that that represents the average rate of change. And the way we determined slope from your last test was y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. In this case, my y sub 2 value is f of a plus h minus your y sub 1 value, which is f of a. And we will divide that by your x sub 2 value minus your x sub 1 value. And notice you get f of a plus h minus f of a, and in the denominator, the a's go away, and so you just have h left over. This is a very important formula that you're going to use when it comes time for calculus. So let's see what happens in this situation here, okay? We start by taking a plus h and plugging it in, and we get a plus h squared. Then it will be minus, then you plug a in, and we plug a in, you get a squared. And that says all over h. Now what we want to do is we want to simplify that expression. And how we will simplify it is we will multiply a top out to be an a squared. And then I'm going to have a 2ah after I FOIL it out. And then an h squared minus a squared all over h. Now what do you notice happens? Sure enough, the a squareds cancel. In fact, if you do this correctly, the anything that doesn't have an h should cancel all the time. You're left with 2ah plus h squared divided by h. Furthermore, you should always be able to factor an h out of the top. You get 2a plus h divided by h. Notice how the h's cancel, and we get 2a plus h. There you have it. That simplifies your average rate of change. Let's try it here. F of a plus h minus f of a all over h. And plug that in, and I get 2 times a plus h minus 3. Minus, now I got to plug this in. And I get 2a minus 3. Careful with your parentheses there, because we have that subtraction. All over h. I get a 2a plus 2h minus 3 minus 2a plus 3, all divided by h. Everything that doesn't have an h should cancel. You are left with 2h divided by h, which is 2. If you notice, this was a line. And what's the slope of a line? It is 2. In fact, you actually just proved that the slope of that line is in fact that value out front. You know, if we did it for y equals mx plus b, your answer would come out to be m. And so you know, it's you used to think you didn't like proofs, and now I tricked you. You did a proof and you actually liked it. Now you're taking it back. You're saying, oh, I don't like it anymore. You all have like a geometry syndrome where you have negative aspirations towards it. It's a fun study. F of a plus h, we'll try this one, minus f of a all over h. Plug the a plus h in into 2 places there. Notice you have 5 times a plus h minus a plus h quantity squared. Minus, then you're going to go ahead and plug a in for both of these situations. And you'll get 5a minus a squared. Notice the parentheses. All divided by h. Multiply it out. 5a 5h minus a squared. I'm going to distribute that negative all the way through after I multiply it out. Minus 2ah minus h squared minus 5a plus a squared all over h. A squareds, gone. 5a's, gone. Notice everything that didn't have an h cancels. And so you are left with 5h minus 2ah plus h squared all over h. Should be able to factor out an h. 5 minus 2a plus h over h. They cancel, leaving me with 5 minus 2a plus h. In letter K, this one's different because it's a fraction. Hopefully you will see the different things that we've taught you so far to prepare you for this moment. So plug that in, we get 2 over a plus h plus 3 minus 2 over a plus 3 all over h. What do you know? You have a complex fraction. Notice we prepared you for that. We must find common denominators. In the top, I get 2a plus 6. In the bottom, I get, then I get a negative 2a, a negative 2h, and a negative 6 over a plus 3 times the a plus h plus 3 over h over 1. Notice what happens. The 2a's go away. The 6's go away. I'm left with the negative 2h. I multiply by the reciprocal. Notice the h's will cancel. Leaves you with negative 2 over a plus 3 times a plus h plus 3. And that is your result. One more. Square root of a plus h plus 5 minus square root of a plus 5 all over h. Now, we would like to get all the a's to cancel. Everything that doesn't have an h to cancel, I should say. But if you notice, these are wrapped up underneath the square roots. So I do this tricky thing. Instead of doing math, I do Spanish. I know Spanish. For example, like yo soy muy guapo. So that means I'm very handsome. What other things can I say that are true? Yo soy muy inteligente. I don't know. Yeah, something like that. Or maybe I could say yo soy muy gordo y feo. I am very fat and ugly. Now you're starting to laugh, huh? Yeah, I'm a funny guy. Instead of doing math, you do Spanish. And you're like, why are you talking about this, Mr. Gantz? This doesn't make any sense. Yes, it does. Because I know a little bit about Spanish. I know this word, hablo. It means I speak. And if I simply just change the end, we talk about that as conjugating the verb. It means you change the ending. For example, hablo, maybe hables. Or hablan. And, whoops, sorry. I'm doing Greek now. So when we are writing languages, we conjugate by changing the ending. And that's the way we say I speak, you speak, we speak, so on and so forth. My language was Greek. When you conjugated a verb, there are 512 different ways to conjugate a verb. So when you're conjugating a verb in Spanish, you have a few ways to do it. Don't get so upset. There's other languages that have far more complexity. But it means you change the ending. So what we're going to do is we are going to write the same thing, a plus h plus 5, and then square root of a plus 5 over square root of a plus h plus 5 and square root of a plus 5. The difference is instead of a minus square root of a plus 5, you're going to write plus. And what's beautiful about when you multiply by a conjugate, I'll show you, a plus b times the conjugate would be a minus b. When you multiply those, you get a squared minus ab plus ab minus b squared. And what happens is the middles go away. The first part is squared and the last part is squared with the subtraction sign. So multiplying by the conjugate gives us this beautiful thing where the square roots are going to cancel. Like the square root of a plus h plus 5 times the square root of a plus h plus 5 is just going to give me a plus h plus 5. And then when you multiply these two and these two, they will be direct opposites and they will cancel. And then you'll get minus, and then this guy times that guy will give me a plus 5. Now, the denominator is kind of ugly. You have an h times this big quantity over there, which is square root of a plus h plus 5 plus the square root of a plus 5. So you kind of got that stuff, but at least the top now, we can focus on that. And look at what you get. A minus a, that goes away. 5 minus 5, that goes away. You get h divided by h times the square root of a plus h plus 5 plus the square root of a plus 5. The h's are gone. 1 over square root of a plus h plus 5 plus square root of a plus 5. And that's your answer. So notice the h is still canceled. Everything that didn't have an h on top canceled. That's your result. We are not going to do the last one. That's enough. But it should be able to take you through 2 worksheets. Your first worksheet, which is evaluating functions, where you're doing things like this. And then your second worksheet, which is using the formal definition for the rate of change and determining these types of values. Now, you're going to have time in class to work on this on Wednesday, but I do want you to know this is an extremely important skill, extremely important skill. And if you could talk to the calculus kids right now, they're going to tell you this is very valuable, and it makes life a lot easier for them, being they were able to look at it a little bit in pre-calc. So there you have it. Hopefully you enjoyed the lesson. 23 minutes. Have a great day.